Yeah, thanks for coming to this talk. So this is work we did over the past year or so. That's also when I was doing the internship at LinkedIn. So the goal is to identify decision makers from social network, in this case specifically the LinkedIn. So this is one of the enterprise applications. We're helping the enterprise customers to provide value. So this is not serving the free LinkedIn.com users. So the goal of this work is to identify what we call decision makers using the LinkedIn ecosystem. So we want to, basically the goal is for each of the members on LinkedIn, we're trying to identify you, like how much decision power you have based on the data we have here. So the definition we have for decision maker is the people that can make or influence a sales decision. So we are looking specifically for sales use case. So the decision maker is not making decision on recruiters or other things. It's for sales use case. So we leverage all the signals we have in the ecosystem that we have. This is right now being used in multiple applications in production. So when people talk about LinkedIn, most people would know we have a LinkedIn.com page. It's free sign up. You can, if you want to additional feature, you can sign up for a subscription. But so that's what typical use case people would see. But apart from that, we also serve many enterprise customers. So one of the products we are doing that is we call Sales Navigator. It's a product we are selling mostly to salespeople. So the goal of this product is if I'm a salesperson, I can use this software to identify interesting customers, interesting leads in the customers. I can follow them, their updates, their job changes. I can reach out to them. So we provide additional tools after on top of LinkedIn.com, sort of free tools. So that's this product that we apply this decision maker score to. So yeah, the key differentiation of this new product is that we are serving sales professionals primarily. There's additional action that you can do, which is not available in freelink.com, is you can save people's lead, meaning that I've looked at this profile, this person looks interesting to my product, so I should save them. So I have a list of saved leads per company. I can follow up on them. I can see their updates. So that's one feature that is not available on free version. And we have some specific functionality for sales professional. So the two things that I just want to highlight two things here. So one is a search. We have a freelink.com people search. So for sales professional, we have a little bit sales flavored search as well. So in this case, you can see that, does this work or not? Oh yeah, that's great. So if you enter a query right here, so you can get the results here, but what you can do is you can add all the facets. You can add like the company, location, title. You can also see how many people who changed job recently, how many people have some connections with you, like they have they were in the same company before, they went to the same university before. You can sort of drill down to different results very quickly. We also provide you additional actions, so you can save people's lead. So this is a very popular feature within salespeople. So the other feature, which is only available on Sales Navigator, is you can actually see the lead recommendation. So if I go to a company page, like in this case Google, besides other things I see in the normally link.com page, I also see people that I may be interested in. So this is based on how powerful, how decision makerness that these people are in the company, also based on my history and my search activity. So the decision maker score is currently used on both products, so that's why I'm highlighting those two. So yeah, that's the sort of motivation for the work. So for the outline, we're going to give a little bit introduction on the ground truth challenge. So it's not like we don't have the real ground truth for the data. We don't know who are decision makers in this case. We're going to talk about the features and approach we do the learning. Then we show some experiments, both offline and online. So it's interesting to see the notion of decision maker. So in the sales context, we don't have really the ground truth. We don't know who is or who is not a decision maker by definition. So, and if you have connection to a customer relationship management software, meaning you know if you sell this product to this customer who actually made the decision. If you know that, you can say, well, yeah, I know this guy made a decision, so he is a decision maker. But we, as a LinkedIn, we don't have that connection yet to the customer information database. So we have to use some signals that we have internally on LinkedIn. So for this work, we use what I call surrogate signal. So we are basically counting how many sales email, meaning the mail. Email is a specific like a mailing application within LinkedIn. So if I got an email from a guy who is classified as a salesperson, so we do have a function classification based on each member's profile. So if I have this many incoming emails from salespeople, that's a good sign that I may be interested. I may be interesting to the salespeople. So this is sort of our signal. We use this to be our sort of guidelines when we're doing the learning. But we also do two kind of normalizations. So the raw number of that email count may not work perfectly. Like sometimes, if I'm a recruiter, if I got a lot of emails from salespeople, but they're not looking for sell to me something, they're looking for find a job in my company. So for the recruiter people, they get a lot of emails. They also send out a lot of emails to reach out to people. So we do discount the number of emails by that ratio. And we also try to do a normalization within the company. So certain company may got a lot of emails in average. And so this score is like a global score. It has to be sort of comparable across companies. So we do another discount based on how you compare to your peers in the same company. So yeah, we have it's a kind of definition of the ground truth, if you will, primarily based on the number of emails you get from sales and has some discount factor. So the question I got from a lot of people is, okay, why do we need to learn? So we already have a definition. So okay, you're good. The reason we need to still learn this is because it's so sparse. So very few people across the ecosystem have any sales email as an incoming message. So we did a sort of a plot chart here, a box chart here. So we're trying to see, okay, this is, so the x-axis is a ranking per company. So think about this as a think of Google. So we are ranking the number of sales emails you get from the 100th to about 2000th in this case. So meaning that, so if you are ranked 100 in the company, you get roughly this many sales email. If you rank lower, you get almost 0. So I did not disclose the real numbers just for sensitivity information. I just disclosed the scale of the email you get. So this is across all the companies that has at least 5,000 employees over last year's data. So a lot of people, if you go down to about 500 here, you got very, very little sales email as a count. Just to compare with other signal, which is what I call profile view. So it's much cheaper for salespeople to view your profile instead of sending you an email. So this is a much denser signal to look at. So this is almost 100x compared to the scale. So so most people get at least some kind of profile view, if you will. So that's why we cannot just use this definition to define the sort of decision maker score. We have to sort of learn it. And we use that to guide our learning. So something about the features. So in this work, we use two types of features. The first one, what I call contextual information. So those are features on your profile, your title, your position, how senior you are, and some of your work experience. So this is something that you provide to LinkedIn on your profile. The other thing is graphical information. So LinkedIn, as you know, has a lot of different kind of graphs. So connection is one graph. We have invitation graph, who sent invitation to and who accepted invitation. We have a profile view. I can view your profile, I can view my profile. And lead save. Lead save is a special graph for a search navigator. So I can save anyone as a lead, as a salesperson. So it's like a one-dimensional directed graph. An email graph is also bidirectional. So instead of looking at all the graphs together, we are actually separating different graphs separately. So we're looking at different graphs in different ways. So in terms of the features, so if you really want to summarize features from the graph, instead of doing sophisticated sort of graph propagation algorithm, you can use the degree, depending on its undirected graph or directed graph. You can compute different kind of graph information to sort of quantify the feature for this member based on the graph information. So I wouldn't go into details of this, so you can do a lot of different kinds of things here. So for the learning approach, we try two things. We try two approaches. The first one is what we call graph summarization approach. This is sort of a very straightforward approach. For each member, you get the contextual information from the profile. You get the graph-based features based on like a degree information. Then you have this label, which we use the sales email to sort of quantify. Then you just make a binary classification out of it. So it's like a very intuitive training with features from graph. The other approach which we are very excited about is what we call bipartite graph learning. So instead of treating all the salespeople, which is the sort of a square person here, equally, and we are trying to see how much power or how much competence you have as a salesperson. So I'm not going to view all salespeople equally. I'm saying, okay, if you are very experienced salespeople, I can actually weigh your interaction much more heavier. So if you're just a new salespeople, then I would view that lower. So this is more sort of adaptive learning, sort of. So we call the score for the blue person here is the DMS score, decision maker score, LinkedIn decision maker score. And we call the other score it's another score for salespeople. And we call that sort of sales competency score, SCS, just a nickname for that. So I just want to visualize this with a little bit of animation. So it's very basic. So suppose you have decision makers on one side. So this can be anyone. Anyone can be decision maker, potentially. And you have salespeople on the other side. So we only look at the bipartite graph. So we don't care about interconnection between this side. So we only care about if a sales guy looked at your profile, save us as a lead, and different other activities. And we use different colors to mean different kind of graphs. You can think of this can be n different kind of graphs. So we start from assuming a same score, let's say for salespeople. Then if you basically do some kind of propagation, you know, oh, okay, because of the input I got from all the salespeople and from my own profile information. So we have different score for the blue circle, meaning the DMS score. And in the next round, I just ignore this graph. I do a different graph, and I try to look at the backwards graph. This can be an email response rate. It can be a profile view backwards. It can be any other things. So I'm going to use the information to propagate back to this side. So we basically do this kind of iteratively until it sort of converges. So mathematically, so this slide needs some kind of explanation. So assume that we have a P score for the blue circle. We have a Q score for the square. This is salespeople. This is anyone else. So it's a function of a linear term. So the X are all the contextual information like title, seniority, your profile, your job description, things like that. So those are static. Those are not graph dependent. The same thing for salespeople. How many years have been in sales functions, things like that. Then we have a graph term. So for the graph term, what we did is for each of the graph, suppose we have K graph here. And for each graph here, we have a term. Then we're going to look at all the incoming edges of the other side, and we weigh your edge with a weight. So the weight is actually learned from the other step. So the weight is Q. So if you are really experienced salespeople, we will your incoming edge higher. And so this can be just the frequency of times that you view my profile. This can be something else, depending on your application. Then we sum all the incoming signals, and we have another weight here. This is really the graph weight. So how important connection graph to me for this application? So I can actually learn this as well. So not every graph is equal here. So the same thing is for the Q score. I have the P computed here. So F here is a sigmoid function. So it's mapping a linear term to a 0 to 1. So if you have P score, do the same thing. So we look at the backward information, all the returning signal here weighted by the weight, sum up, and with a weight for the graph. We do the Q score. So you can think of this. So if you do this iteratively, you can actually converge. So we have seen this in experiment. It's pretty fast convergence. So just trying to draw some connections to some existing methods. So if you fix all the Q to be 1, meaning that I don't learn the weights for salespeople, so I just fix everything here. This can be thought of as a graph summarization, like a basic learning algorithm. You basically have all the features, static or graph-based. You learn a single logistic regression kind of model. So that's a special case. And if you fix K to be 1, there's only one graph, and you allow 0, so there's no other features instead of the graph, then this is a special case of the sort of label propagation algorithm. So it's a bipartite graph, label propagation. You propagate label only. There's no sort of features that I need to learn. If you don't have any ground truth, this is actually a special thing for hits for bipartite graph. So this has some nice, so it's a nice extension of other algorithms that's been used by a lot of people. So this sort of summarizes the key learning approach. So in terms of experiment, we look at the network data last year. We do a random split of LinkedIn membership, 70% and 30% for training and test. We took that sort of subjective ground truth we defined, and we sort of binarize that. We make it binary, and we use some kind of internal threshold here to make it binary. We just ignore the cases that are not sure. Then we try a different approach. We use ElasticNet in this case. You can use any classifier. So we use ElasticNet to train the two approach. And for the graph learning approach, because we have to have those testing members in the graph, so we use them, but we don't know their actual label. So for experiment, we use two metrics. One is NCG. This is standard for ranking. The other one is Kendall's tau. This is more for correlation analysis. I think if you're a statistician, you tend to use this more. If you're a machine learning person, you tend to use this more. So depending on your expertise and your preferences. So this is some basic information about these two different metrics. They have pros and cons depending on how you look at it. So we did a offline. So we basically say, hey, we have 70% training data. We know the ground truth. We train both models. Then we have testing data, 30%. We don't know the label at training. So we look at those two metrics across a different K. So meaning you cut off at a certain point. You compare how good is the ranking that you have compared to the ground truth. So the graph learning approach is a little bit better than the baseline. So both are pretty good, but the graph learning has an additional edge there. And especially for the Kendall's tau, if you have a larger K, meaning you look at more in the list, you tend to do better with the graph learning approach. So we also look at one thing that if you use different graphs, so okay, we have different graphs, and if you use more graphs, does that improve the results? The answer is yes. So across the board, if you have more data, so you have, instead of emails, you get profile view and other lead save graphs, so it tends to be slightly better across different top K. So meaning adding more graphs, adding the value, and adding the relevance here. So this is one thing, we're just trying to plot the score to see how the score looks like. I don't want to give the sort of the scale, but yeah, but this is basically for the decision maker scores you can sort of think of. Most people are pretty low. So most people on LinkedIn, they are not decision maker per se. They are regular members. So there are a few people on the other side here. So you cannot see this, but we have some people there. So there are mostly pretty senior people in the company. So it's kind of a power law distribution. It's sort of dropped pretty quickly here as a histogram. But for the sales competency score, it's kind of in the normal shape. So most people are okay, and some people doing better, some people doing worse, but they're not like power law shape. That's interesting observation. Okay, let's go online. So we implement this score in production. So we do at least a weekly run. So we take all the features, we do a weekly run right now. So we apply this in two different ways. One is the lead recommendation, which is a brand new feature. So there's no way to do A/B test. This is for the research ranking. So basically, because the idea is for sales application. Yeah, thank you. For sales application, you want to show people that has a high decision maker score, meaning those people are more interesting to salespeople. So it's not just a content match. So if I search VP marketing, you can do a matching of your profile, but you also want to pop up the people that has a high score on that side. So people are interested in you from other signals. So one thing we did is we just use DMS score to re-rank results for search. And the signal we look at as a sort of the signal is how many people click the save button. So meaning I save this guy as a lead. So we look at, this is a key feature for this product. So the more you save, the idea is that the more you can follow up and the more value you get out of it. So we try to compare with the current search, well, previous search, without having any consideration of the DMS score. So we use the first approach, which is a standard approach. We see a 4.5% lift on this metric. And we do another more graph learning approach. We see another 10%. This is on top of the first approach. So they give us a significant improvement over the key metric here. Okay, to summarize, we present this score. We call that LinkedIn decision maker score. So we believe this score can capture the sort of the perceived value from salespeople's perspective. We have tried two different approaches here. The approach is pretty general. You can think of, forget LinkedIn, if you look at Facebook, if you have different sort of entities on both sides, if you have different graphs between them, you can think of some similar application to this, try to apply this kind of graph propagation to learn information on both sides. So it's pretty general. It's not just for LinkedIn, per se. So the algorithm is pretty generic, can use both contextual, which is static information, as well as the graph information. I think that's it. Any questions?
Yeah, I think for now this is bipartite graph, and
right.
Do you think the internal connections between nodes would also be helpful to reinforce your knowledge you're learning?
Good question. So we thought about this at the beginning. So we believe the most value is between the two bipartite graphs. There's one assumption that if I'm a salesperson, my connection may be also a good salesperson. So you can sort of leverage within each bipartite information. We haven't tried that idea yet, but because we believe most information is going across. And the salespeople are in the left side as well, because they can be a decision maker. So we sort of use that information in some ways. Thank you, that question, good.
This reminds me of PageRank, right? So can you explain the difference?
So the question is, how is this different from PageRank? Okay, so PageRank is a sort of unsupervised learning approach. So basically you take the graph and you're trying to look at sort of the topology of the graph and trying to propagate. You're trying to find basically the key pages over the entire graph. But in this case, it's a supervised learning problem. So we're not giving a graph. We don't know anything about it. We're trying to craft some labels, and we have some labels to check, and we have features that we can leverage. The key difference to some other sort of unsupervised learning problem is we don't want to find influencers on the graph. So those people may not be what we care about. We care about people that can make decisions, and we have some labels for that. So instead of just finding all the sort of influencers on the graph may not be a decision maker for our use case.